Continuing on with section 4.1, which is going to cover scatter diagrams and correlation. This is going to have a lot of different objectives that we'll have to learn about, so let's get started. The first thing we want to learn about is scatter diagrams, or scattergrams as they're called sometimes. So the thing to notice about this chapter is this is the one chapter in our course we're going to be working with bivariate data. That's when you're working with two quantitative value variables together simultaneously. Which is a little bit different than a weighted mean. It's more that you have two variables that you think are correlated, that you think they have some relationship, and you're trying to get at that relationship. All right, so the following scattergram, shows the relationship between the number of children per woman in a country and the country's average life expectancy in 1962. So the table shows a few of the countries in the data set. All right, so here are the countries. Not all of them, obviously. There's a whole bunch of them. And then here's the fertility rates, the number of births per woman, and the life expectancy. So you can see the U.S. in that time frame, women were having about 3.378 children per woman, and our life expectancy was about 70.21 years. So a baby born in 1962 was expected to live about 70 years. Right? So here they are, right here. And you can see you have kind of a relationship going on here, and we want to get at that relationship. We want to see why these are high, right, for the life expectancy, low for the fertility rate, and these over here on the right are high for fertility rate but low for life expectancy. So what is the predictor variable? Well, the predictor variable is, in this context, kind of the independent variable, the x. So that is the fertility rate. Right? The response variable would be the life expectancy. All right. And the units for fertility rate are births per woman. The units for life expectancy are years, but the variable itself was life expectancy. Now, what was the U.S.'s fertility rate? That was 3.3. Oops. Whoa. I hit something with my mouse. Hold on. Sorry about that. All right. 3.378. It was right here on the table. If I didn't give it to you in the table, you wouldn't know it. It's not like you can magically look at these dots and know which one it is. All right, so the Middle Eastern country of Yemen had a birth rate of 8.37. Wow. Births per woman, that's a typo. Sorry about that. Births per woman. And a life expectancy of 35 years in 1962. Circle and label Yemen on the graph. All right, so Yemen, 8.37, that's over here. This dot right here. So let me draw that. Hold on one sec. There we go. So Yemen's right over here. There it is, circled and labeled. All right, so what type of data is the response, or excuse me, is the variable fertility rate? Okay, fertility rate is births per woman, and you can see it has a lot of decimal places because it's a rate. So what they're doing is averaging it out over the large amount of groups. So that's quantitative continuous. I'm going to underline this one. This is the one. Actually, let me give it a little box. Hold on. There we go. All right, now what about what level of measurement fertility rate is? Okay, well, the level of measurement is ratio because it's a number, but it can't be negative, right? Negatives are interval, or things that can be negative are interval. So it's this one, it's ratio. Let me give it a little box. Box. There we go. All right, now let's see what type of variable is life expectancy. Well, it's the same thing, right? Again, it has variables decimal places, and it can't be negative, so it's numerical, all that good stuff. And there you go. All right, now what type of relationship do we see between the variables? As fertility grows, life expectancy decreases, goes down. This is called a negative relationship, right? So as the one thing goes up, the other thing goes down. So over here on the right, we have high fertility rate, low life expectancy. Over here on the left, we have low fertility rate, high life expectancy. See? Okay, so then in 1962, the terms first world and third world were coined. Explain how the graph reveals the differences between these two groups. Okay, so the first world is the long lives and small families, to quote Hans Rosling, where a lot of this comes from. He's a famous, actually, professor in Sweden who popularizes where this comes from, and I'll show you in a second. Short lives and large families. Now, what's interesting is those phrases, the first world, the third world, they were coined in 1962. Oh, and by the way, in case you're curious, the second world was considered the Soviet Union and its sister states, in case you're interested. Students are always like, well, what's the second world? Right? So first world was long lives, small families. Third world was short lives and large families. And it's interesting to hear people talk about it today. And they'll say things like, oh, well, such and such is a third world country. And I do not think it means what you think it means. So let me show you this real quick. I'm going to click on this link here. There we go. So this is Gapminder, Hans Rosling being one of the brilliant people behind this. It's an online worldwide database that has all sorts of information about the world. And you can see it starts off right now in 1950. You can see because it says 1950 in the background. You'd be amazed how many students are like, yeah, what year is this? It's 1950. All right, so then we want to look at 62. So let me show you 62. Oops, there's 59, 61, 62. There's 62 right there. And you can see very clearly there's a first world right here. There's the U.S., in case you're interested. You got Italy, Germany, Russia, Slovenia, Ukraine, right? So you got the second world in there and the first world. The Netherlands, Norway, etc., Iceland. And there's a third world, which is all these countries over here. Okay. Now, if you press play, you can actually watch it change over time. There's the 90s, there's the 2000s, and there we are in 2012. And this is the majority of the countries in the world now. And then there is still this little third world bit, what counts as the third world. And the vast majority of these dots are this deep blue color. That would be sub-Saharan Africa. Right there. See them? Right there. So that's where a lot of poverty and economic disparity still thrives, unfortunately, for a variety of socioeconomic pattern reasons. But there are all these countries that are not nearly as far away from the U.S. as people would think. Like, for example, Iran. A lot of people are like, oh, Iran's a third world country. Really? Iran has a life expectancy of 74 years. The U.S. is 79. They're not that far apart. Right? So Vietnam, the United Arab Emirates, Mexico, there are a whole bunch of countries in here that a lot of people think of sometimes perhaps as the third world, but they're not the third world. That's an erroneous assumption that people are making. Right? So there you go. Interesting, huh? All right, and you can play around with this. You can send it back different years. You can look at it in the 40s and 30s. Like there's World War I, or World War II, excuse me, going on. And you can watch the dots kind of have problems in the 40s. You can see, right, Germany went plummeting down by the end of the year, right, the end of the year of war, that kind of thing. So it's kind of depressing, but that's the way it is. There's Japan at the end of World War II, etc. And then after the world wars are over, then the dots kind of start floating upwards. Right? So fascinating stuff. I enjoy it greatly, and you'll have to get some data from here for one of your projects. So enjoy. All right. Now, as I was saying, this relationship that we're seeing here is called a negative relationship. See that? Negative. All right, so that's getting at this part right here. The kind of relationships we're the most interested at in this course are positive linear and negative linear relationships. Positive linear is also called a direct relationship, and negative linear is called an inverse relationship. Those two are the two we actually care about. Now, there are a whole host of other relationships that are nonlinear. Exponential relationships, quadratic relationships, there's tons and tons of them. We're not going to be dealing with them in this course. If you want to deal with them more, that would be a Stats 2 course or something like that. We're also not really interested, well, we are in so much as noticing when they happen, but there are patterns that have no correlation whatsoever. It looks like somebody just vomited the points up there. That's not a correlation, right? So, for example, shoe size and IQ. Right? That doesn't have a relationship. People with big feet aren't necessarily smarter, etc., etc. Although I have big feet, so maybe I am. No, just kidding. All right, so nonlinear patterns are definitely patterns. They're just not lines. And so we don't care about them so much. at least for the purposes of this course. And then no relation is when there's no patterns at all. So don't confuse the two. All right, so now let's look at these. We want to try to judge whether the pictures we have here are linear. They are all linear. We want to judge whether they're positive or negative. That's the direction. Like, are they positive, negative, and what's their strength? Are they a perfect relationship? Are they a strong relationship, moderate, or weak? Okay, so let's look through all of these. All right, so it's kind of obvious what this one is. This one is perfect, negative. Hopefully you can all see that. Perfect is when all the dots form a perfect little line. That's perfect. All right, so that's perfect negative. Over here is perfect positive, right? Because they're all forming a positive sloped line, right? So, and don't forget from algebra class, this is a negative slope. This is a positive slope. You always read graphs from left to right. All right, so then this one over here, that's strong. That looks like a strong, positive relationship. Again, it's climbing as you move from left to right, so that's positive. All right, what about these two? Well, this is a little bit hard to tell. Is this strong? We know it's negative, that much is sure. But is it strong or is it moderate? What about this one over here? Is that moderate? Is that weak? It's negative for sure. I can tell it's negative. But maybe it's moderate or maybe it's weak. Ooh, who knows? Not really sure. Down here, this is positive for sure. And that, I think I'm pretty good with saying that's moderate. But who knows? Maybe somebody else would think that's strong. And now you're seeing the problem. We want to be able to judge strength, but it's kind of hard sometimes. I mean, does this count as strong? Does this count as moderate? Like, what's the threshold? So, okay, mathematicians generally don't like that kind of wishy-washy talk. No, sir. We want a number that's going to measure it for us, right? We want some kind of number that we can say, aha, I don't need your picture. I don't want to look at a picture. I just want to be able to say, yep, the number is here, so that counts as strong. The number is here, that counts as moderate. And so we invented a number called the correlation coefficient, right? So it's going to measure the strength and the direction. It's going to give us an idea of how strong our relationship is and what direction it is. It's also called the Pearson product moment correlation coefficient. It's R. Sometimes it's capital R, sometimes it's lowercase r, it just depends. Now, R is a number that is always between -1 and 1. It never gets any higher than 1, never gets any lower than -1. If R is 1, that's a perfect relationship. Positive relationship, excuse me. And if R is -1, that's a perfect negative relationship. And the closer your number is to 1 or -1, the stronger you are. And the farther away you are from 1, the weaker you are. All right, so let me fill out these pictures right here. So this would be a strong negative linear, or excuse me, positive. I already did the negative. Positive linear relationship. If you're after 0.8 and higher, you've got strong positive, -0.8 and lower, strong negative. If you're between the 0.5 and 0.799999 range, that's moderate. Moderately strong, moderate. Okay, so let me type this in. Hold on one sec. There we are. And then anything smaller than 0.5 in size, so from -0.49999 to +0.49999, anything in there is considered weak. Okay, let me get you a picture of this on the number line real quick. Hold on one sec. There, that's kind of the best I can do. It's a by hand drawing that I did in class. So you can see over here is strong positive from 0.8 to 1. Over here is strong negative from -0.8 to 1. Here's the moderate positive. Here's the moderate negative. And all the stuff in between is the weak. All right, we'll stop here, and I'll see you back here for the next page. See you then.